Now we're going to have a look at doing a cross-tabulation and a chi-square test. Let's go into Analyze, and don't go into Tables because that would be a very logical place to look for a cross-tabulation. Instead, go into Descriptive Statistics and Cross-Tabs. Just leave that there for a second. Now I'm going to take those out and start again. Mathematically, it doesn't matter which way round you put in your two variables. In terms of what you've done in class, you might want to put your exposure variable in as your rows and your outcome as your columns, and that would be fine. And when you come to calculate, or get the computer rather to calculate any risk or odds ratios, it will do it all in a certain order, and so that's where you probably need to be more careful about which way around you put stuff in. If you get answers out that don't look quite right or you need them in a different way, the first step is probably to go in and put stuff in the other way around. If we want to put our exposure in as our rows, in this case the exposure would be race, but this isn't really an experiment, obviously. We can't assign the race, and then the outcome is whether or not the baby is low birth weight, so we'll put that in as the column. And we'll just stick with the basic cross tabulation to start with. If you want to, you can click this here and get your clustered bar charts out. This will be exactly the same as the basic clustered bar chart that we started with. But if you haven't already done this for some other data, you might want to see that as a first step as well. So we've got here the bar chart that we've already seen, so we probably don't need to look too much of that. The case processing summary is just where SPSS will go through and just count up. It looks like there's a few missing values here, so that might mean for some of the babies they weren't able to collect data on which race their mother was, and it'll just ignore those rows. Now this is the bit that we're interested in, the cross tabulation. So we've got the race of the mother, and then we've got whether or not the baby is low birth weight. When we did the graph, it looked like there were no Mexican babies that were low birth weight, but it's possible that the number was just very, very small and we couldn't see it. But if we now look at the cross tabulation, we can see that it actually is 0. And we can also see that there were far more white babies than any other race as well. Now what the chi-square test of association does is it looks to see is if there was no relationship between the race and being low birth weight, what would we expect to see? What numbers would we expect to see across each of these categories? And what it does is it calculates the overall percentage of low birth weight babies, and it'll say, okay, if there are overall, I better pause the video and work out what that is. Okay, so I've opened up the little calculator so we can see the calculations. If we overall have 62 low birth weight babies out of a total of 1,208 babies, that would give us our overall rate of low birth weight babies, and that's about 5%. So if there was no relationship between race and low birth weight babies, we would expect to see about that rate of 5% across all the races. Now, because we've got 858 white mothers, we would expect about 5% of them to have low birth weight babies. So if we times this value here by our white mothers multiplied by 858, we could expect to see about 44 low birth weight babies. Now that calculation we can do for every category, and it's not too difficult. It can be a little bit time consuming depending on how many categories you've got, but SPSS will do this for you, and these are called the expected numbers. And by expected it means what we would expect to see if there was no relationship or no association. So if we go back into Analyze and not Tables, into Crosstabs, in the Cells button we see the observed, and that's what actually happened, which we've already got. We can also have a look at the expected, and that's what I just demonstrated before. Continue. We probably don't need to see that graph again. Okay. So now under each observed count we can see the expected count. Now there's the 44, which we worked out a second ago. We could also go through and have a look at what 5% or approximately 5% of each of these other races would be. And so that would say if there was no relationship between race of the mother and whether the baby was low birth weight, we would have expected to have found about 2 low birth weight to the Mexican mothers, 12 to the black mothers, about 2 to the Asian mothers, and about 1.3 in the mixed category. Now, actually, what it seems like we got a lot more low birth weight babies to the black mothers than we would expect. We got about double. And we also had a lot fewer white low birth weight babies than we would have expected. And the question now is this statistically significant? Now, again, the calculation for this is actually not too hard. We just make a comparison really between each of these numbers, and we do some adding up and some dividing. It's a little bit time consuming, but you can look up the formula if you want to. SPSS will do it for us, of course. So back into descriptive stats, crosstabs, and then statistics. And what we want is the chi-square test. And this is going to test the null hypothesis that there is no association between the race of the mother and whether or not the baby is low birth weight. And it's going to do this based on those expected counts that we just had a look at. Okay. So now we get exactly the same thing again, but we get this extra little box at the bottom with the chi-square test. So if we just have a look at the outcome of the test, it does say that we have a significance of 0.001, which is very small. So that's, this yellow box keeps coming up. Let me click off it. No, go away. Right, there we go. So we've got very strong evidence against the null hypothesis, and that would indicate that there actually is an association between race and being low birth weight. But we've got a warning down the bottom here, and that says that 3 cells have an expected count of less than 5. And you'll notice that it does say expected, not observed. So the way that this test is done is it doesn't matter if you get a very low observed count, but if you were expecting a reasonable number of counts in each category, then the test is fine. So if, for example, there were about 50% low birth weight and 50% not low birth weight, then rather having a 2 in this category, we would be expecting 20 to be low birth weight, and so we would have a high expected count, and then the test would be fine. But because we're trying to pick up a really small percentage of about 5%, and some of these categories don't have very many people in them, it's going to be much harder to find out if something is statistically significant. So this warning down here is just letting us know that this test is probably not too reliable because we have 3 cells with the low counts, and that would be the mixed, the Asian, and the Mexican. So there's a couple of options here for what you do next. Now, one thing you can do, if you're really only interested in the difference between white and black, what you might do is temporarily ignore these other 3 categories and just run the test again between white and black. On the other hand, you might think that it's not a case of whether or not you're actually black. There might be some other factors involved around minority groups and perhaps social disadvantage, and so it might be sensible to group all the minorities together so you've got a white group and a non-white group. The interesting thing was that there were no Mexican babies with the low birth weights. Now, I don't know if that's just due to random variation, or if there is something different about the Mexicans as a social group wherever this study was done. So you can't really do good statistics in a vacuum. You would have to have some expert knowledge about the community you're working with and whether or not it's sensible to group all of these races together, and it might not be. And we'll have a look at how to recode variables in another video. But from here, we wouldn't rely on this result. We would say that this result is unreliable because we have 3 cells with an expected count of less than 5, and that's one of our assumptions of the chi-squared test, is that we don't have too many low expected cell counts. The 5 is just a rule of thumb. If you had one expected cell count of 4.79, then you might still run the test. But in this case, I think we really don't have enough in some of these categories.